had on this project. The law of conservation of energy. That's pretty simple.
What are you doing, Mimi?
I'm just following the law of conservation of energy.
What are you talking about? That's not it.
I'm conserving my energy.
No, that's not physics.
Well, then what is it?
I don't know. What is
This is what it is. And then, okay.
The law of conservation of energy states that the energy of interacting bodies or particles in a closed system remains constant.
In simple terms, energy cannot be created or destroyed.
Gravitational potential energy, or PE, is the energy stored in an object when the height is more than 0.
The gravitational field strength constant, also simplified as G, is the amount of force on Earth per each kilogram of mass. It's usually calculated as 9.8.
The kinetic energy is the energy of an object due to motion.
The mass is the amount of stuff that an object has.
Force is push or pull, sorry.
A way to find velocity is change in position over change in time. In this experiment, we are proving the law of conservation of energy by releasing a tennis ball and observing if the ball returns to its initial position. Nice! Success number 1! Since Tomas believes so much in physics, don't you believe in physics? He's going to release it from right beside his nose. So, a tennis ball really hurts if you get hit in the nose. But because of physics, we believe that the tennis ball won't hit his nose because it's just far away.
And because of the resistance of the air.
As we're going over this,
Yeah.
just say we use
The X is the thing that changes.
Perfecto! How do you say it in Portuguese?
Perfect.
Perfecto, or whatever, yes. What we found was a potential energy, and that is mass times gravity times height. Now we're gonna see someone really smart do some really fast math, and it's gonna be riveting, okay? So just watch, it's gonna be awesome.
You're going to speed
No.
this up in the editing.
Yeah. So Jonna, while we're waiting, you wanna hear some jokes?
Sure.
All right. This one person of hair color, you can decide, walks into a bar and a brunette ducks. Get it? Bar. Ducks. It wasn't very funny. Sorry, folks.
Are you serious?
Okay, I have another joke for you. What did... Okay, one time there were these muffins in an oven. And it was like, oh, what's up, muffin? And the other muffin was like, oh my gosh, a talking muffin! I think that's on a shirt somewhere.
I heard of that.
Do you have another joke? And the height that we're measuring, if you'll follow me, Thomas, you don't know. The height we're measuring is from where this is 0 to where we released it. So from about here.
Excuse me.
Yeah.
Oh, no.
So this is the height that we measured. Does that make sense? Awesome. Now, put it here.
My fault.
Yeah, why don't I explain that real quick? Because we're on Earth, the air that the ball is touching right now gives it friction, which means that it's gonna slow down after a while. But if we were on, say, the moon, which doesn't have gravity, then the ball would keep going forever and ever.
So right now, our group is recalculating the heights where we held the ball and threw them towards each other. Because we did. Now these are the 5 new heights listed.
So this is the math part of the whole problem. We found the potential energy, which is mass times grams times height. And I explained earlier what
That's
the height
gravity.
was. I mean, it's awkward. Mass times gram.
Gravity.
Okay, start over. Take 2. What we found was a potential energy, and that is mass times gravity times height. And we already explained how the height worked. So the mass of the tennis ball was 0.059996 kilograms. The gravity equals 9.8 meters per second squared, and the height is up here. So then we found the math.
Measuring from
So the
measuring from the distance.
Just the driver arm, I can actually record.
joules.
Yeah, they use
No, it's
joules.
big.
They use joules.
Yeah.
It says joules on the thing. It says joules.
Oh, gotcha.
Just
Yeah,
joules.
it's joules because it's the energy unit.
Okay. Back in. Okay, so at 0.92 meters, the height of it,
What we're doing here is trying
the potential energy, is this awkward?
Yeah. What?
Is this awkward?
What?
Us videotaping at the same time?
Yeah. No, we're not videotaping yet.
Not really.
Oh, you're not?
No, we're trying to practice run.
Are you sure?
Yeah.
Okay, awesome. So what we found was the 0.92 meters. The potential energy was 0.54 joules, and so on.
10 times all the way.
Awesome. Okay, you can stop recording.
20.
The law of conservation of energy states that energy cannot be destroyed or created. We proved this with the tennis ball because each time we threw it, it returned to its initial position. This proves it because in any object, it needs the same amount of energy to return to its initial position. Therefore, the law of conservation is true. Yes. So, I would call this experiment a success. Thanks for watching. Law of conservation of mass. Awkward. Thanks for watching Law of Conservation of Energy experiment. I'm Mimi. He's Tomas. And she's Jonna. And this was our group. Thanks a lot.